Hello everyone. Class 12th topic name preparation of chloroalkane from alcohol which will react either with PCl3 or PCl5 or SOCl2. These reactions we will understand with the help of mechanism also. Like in simple way, if we want to learn them, they are very easy to learn. Alcohol if reacting with PCl3. So whenever PCl3, PCl5 or SOCl2 are there and they are going to replace they are going to react with alcohol, so only one work they have. OH will be replaced by Cl. So when OH will be replaced by Cl, you will get RCl. In the case of PCl3, the side product will be H3PO3, phosphoric acid. Reaction will be balanced 3 3. And if alcohol is going to react with PCl5, same technique, OH will be replaced by Cl, so RCl, side product will be differ, POCl3 plus HCl, ROH plus SOCl2, again the same, OH will be replaced by Cl, RCl, and side products will be sulfur dioxide gas and HCl gas. So if directly we want to learn, we can learn them very easily. Role of PCl3, PCl5, SOCl2 is just to replace OH by Cl. Not only in alcohol, like suppose we have carboxylic acid, COOH, and we are going to react it with PCl5. So what will happen? OH part will be replaced by Cl. So RCOCl, acid chlorides will generate. You can use PCl3 also here or SOCl2 also here. Now one by one, let's understand their mechanisms. Like with PCl3, what is happening? So this product is generated with PCl5 and then with SOCl2. First with PCl3. In PCl3, this is the condition. Phosphorus is surrounded by 3 chlorine, phosphorus trichloride it is. Now because electronegativity of chlorine is more than phosphorus, so the 3 electrons of phosphorus are going toward chlorine, due to which it is adopting partial +3 charge. And when we are bringing it in front of alcohol, in which oxygen is carrying a negative charge due to higher electronegativity. Oxygen is more electronegative than carbon and hydrogen, so it is carrying a negative charge. So we can easily judge that phosphorus with a positive charge, oxygen with a negative charge, oxygen will attack on it. Due to this attack, one bond of obviously chlorine bond will break, and suppose this bond is breaking, and when bond will break, both electrons will get shifted toward chlorine due to higher electronegativity of chlorine, and oxygen will make bond there. So next molecule will be this. Now oxygen will make a dative bond with phosphorus with this lone pair, so here only one lone pair now. Now when oxygen is making dative bond with P, a positive charge will develop over it. And from here already Cl negative is released out, which I am writing over here, negative particle. So now oxygen is unstable. How it will stabilize itself? By breaking bond from hydrogen, and both electrons obviously will shift toward oxygen because oxygen is more electronegative than hydrogen. And from here H positive ion will release out because this hydrogen have lost its electron. With vacant orbital it will release out. Now this part will turns to this, and from here HCl will release out like this. Now H positive Cl negatives will combine and they will create HCl. We know HCl is a strong acid, so strong acids always break and provide H positive ions. So again I am breaking them in two parts, Cl negative and H positive. Now here, because oxygen is more electronegative than R, so this R is carrying partial positive charge which will be attacked by this released out chloride. It will be a backside attack. SN2 mechanism will happen over there. Now when Cl negative will attack on R, bond between oxygen and R will break and both electrons will shift toward oxygen, due to which RCl. R and Cl will combine with each other and dative bond will be between them, R and Cl, and this negative charge of oxygen will be satisfied by this H positive. And then we will have this product. RCl is generated out over here. Now, still we have two chlorines over there. Like this whole process was done by this chlorine. Again, I am repeating, PCl3 reacting with ROH, oxygen carrying negative charge, phosphorus is carrying positive charge. So oxygen attacks on phosphorus, bond break between phosphorus and chlorine. Cl negative is released out, which will attack on H positive, HCl. But HCl is a strong acid, will give back H positive and Cl negative. Now here, oxygen is more electronegative than R, so Cl negative will attack from backside, which we call SN2 mechanism. On the R part, carbon part, between R and O bond will break, electrons will shift toward oxygen, R will release out as a positive particle, Cl negative is there, so they will generate RCl. Now oxygen will carry a third pair, due to which oxygen will have a complete negative charge, which will be stabilized by this H positive, which have again a vacant orbital on it. So OH will generate out. So this was our product, the main product which we want, RCl. But still two chlorines are available. You can check here. Two chlorines are available. Now same process will happen again with this molecule. Another ROH particle will attack on it with the same procedure and another RCl will generate. This was the first RCl molecule. Now again second RCl molecule. Suppose from this chlorine you are bringing out this mechanism, and after this chlorine one more chlorine will left out over here, that is this one, third chlorine. Same mechanism will happen with this third chlorine. Means how many times RCl will generate? 3 RCls will generate, because 3 chlorines are available there which are repeating this mechanism one by one with 3 alcohol particles. Due to which one PCl3 particle is reacting with 3 alcoholic particle, creating 3 RCl. And finally, on this phosphorus, we will have 3 OH groups like this, POH, OH and OH, and P will have a lone pair over there. So this is known as H3PO3, phosphoric acid. So this is the mechanism that how alcohol react with PCl3 and it creates RCl and side product phosphoric acid H3PO3. In next video, we will check how PCl5 reacts with alcohol. Thank you very much.